welcome back, everyone. That we are going to be moving on to our next program that we're doing on the Aurora Citizen Science Aurorasaurus program. We have we have 3 people that are going to be presenting today, and I'm going to just introduce you first to Elizabeth McDonald. And then Elizabeth, would you let me see if I can just get you up here to spotlight you. There we go.
Huh?
And
hi,
yes, we can hear you.
Can you hear me?
Yeah,
excellent.
I can. Thank you. Good. Elizabeth McDonald is a space physicist at NASA Goddard Space Flight Center. She leads a citizen science project called Aurorasaurus, which uses citizen science and social media to map the northern and southern lights. In 2018, McDonald announced the discovery of a new aurora called Steve. Strong thermal emission velocity enhancement. That's the first time that I have heard exactly what all that means. That's great. She's been studying the Northern Lights for about 25 years, and it never ceases to amaze her. In addition to doing citizen science and outreach, Elizabeth McDonald has also led teams that build instruments to measure charged particles in the space environment for NASA and the DOE satellite and rocket missions. And with Liz today is Chris Ratzlaff and Jeremy Kuzub, who is a member of the Ottawa Center. So I'm going to give it back to you, Elizabeth, and you can take over from here. We're looking forward to it. Thank you.
Great, thank you so much. And we will be introducing and getting to know Chris and Jeremy, who are amazing Canadian and Aurora enthusiasts during our talk here. And thank you so much for sharing the slides, Chris. I am actually working remotely for NASA from currently in a dark sky place in Northeast Oregon. So amazing view of the sky here. But yeah, really happy to be here today. And thanks to Roland for the invitation and to follow that great talk about 3D printing. So on the next slide, this is what we'll be covering here. I'll just give a brief introduction to my project, and then I'm super happy to pass it on to Chris, who leads the Alberta Aurora Chasers, and Jeremy from Ottawa to talk more about his project involving the Aurora. So you've already heard my background, and actually we can skip to the next slide. And I'll just start with the takeaways here on the next slide. So we've started this Aurora Citizen Science project where we can collect photographs of Aurora from all over the world. And in doing that, we've, as you heard, been able to do some great science and also get to know people, enthusiasts all over the world, and build things together. So that's been really cool. We are very much looking forward to doing that as the sun becomes more active in the next couple of years. And in this solar maximum 2024 to 2025, in addition to the amazing photographs captured by amazing photographers all over Canada and the northern US, there's going to be a lot more smartphone cameras that can capture Aurora. So that's really just going to explode the number of pictures that are available, because there's actually always more people than there are clouds. And so that helps us build up a really good view of this dynamic, very large scale Aurora that you're so fortunate to be able to see across Canada. And if you haven't seen it, it's visible more often than you might think. And so our project was designed to help people get the word out about when they can see Aurora by actually contributing from people who have seen it. So you can go to the website, it's aurorasaurus.org. This is a NASA and US National Science Foundation supported project. It's a type of citizen science where anyone can be doing science with photographs Like you see in the upper right of this slide, sometimes the aurora does very unusual things for very short amounts of time. And that helps us understand the larger space environment, which is also important for protecting some of the systems on Earth that respond to that environment. So we actually do want to, there's a very important role for citizen scientists to help document how far south the aurora is, and also the unusual things that it can be doing, which you will hear about more soon. Okay, next slide. I think the next slide shows a snapshot of the Aurorasaurus website, what it looks like, which is it has a map of where the aurora is visible, and then you can see pins that are people's reports that they have seen aurora. And also we pick up on social media reports, tweets about aurora even, and people can help us determine if those are real-time observations of the aurora as well. And then we do collaborate with a really awesome group of aurora ambassadors from around the world, two of whom you're about to hear from, who are leaders of their local enthusiast groups as well. And if you register for Aurorasaurus, you will, you don't have to register, but you can get alerts of when the aurora is visible. And also, unlike many of the apps, you can actually get an alert from when citizen scientists around you are reporting aurora, which is a stronger alert that you might want to go out and check out. Okay, the next slide. Next couple of slides talk a little bit more about what kind of aurora we can see. Actually, this is a great place to go, the Ovation Prime model. You can see that the auroral oval moves all around the Earth. It is, of course, symmetric on the north and the south. And this shows the kind of a big blob of where aurora might be visible. And people can actually be seeing the aurora quite a bit further south than this model, which shows where the aurora would be overhead. So you can always see it to the northern horizon if you have a clear sky view. And happy to talk more about that if we have more time afterwards. On the next slide, shows some of the different types of aurora, and you're about to see many different amazing photographs of that. But the different types of aurora actually are characteristic of the different kinds of physics of the near Earth space environment. So early in the night, you may see very quiet arcs or these diffuse glows. Late in the morning, you can see these really dim but spooky kind of pulsating patches. And then there's this new thing called Steve, which you can also see typically happens before midnight as well. So understanding the type or reporting on the type of aurora that you see, if you know it, is really helpful as well. And then the next slide, just to briefly finish kind of an aurora overview here, is a really great visualization that Jeremy made of the different colors of aurora and the different wavelengths and what they are caused by. And so the main green that we're all familiar with is caused by oxygen, and there's kind of a peak of oxygen around 100 kilometers. And that's as the particles from space rain down on the atmosphere, that's what causes the bulk of the green light. If those particles are really energetic, they can hit this little layer of molecular nitrogen below that and cause some very pretty, very fast moving purple emissions. And you can see those particularly if you go up north to somewhere like Yellowknife. And there's also kind of a blue layer from nitrogen at higher altitude. And then you can also see the red that is very high up. And very, very high up, there's not very many particles. And so if there aren't very many collisions, that red light will come out. It takes a lot longer, like 2 minutes for those photons to come out. So that's a little bit of how those characteristic colors of the aurora are built. And you can learn more as well in our blog, blog.aurorasaurus.org. And we have all kinds of fun features, and we'll be sharing more of those throughout the talk. So I'm going to pass it on to Chris, and very happy to speak here with Chris and Jeremy.
Thanks, Liz. Hi, I am Chris Ratzlaff. I'm a citizen scientist with the Alberta Aurora Chasers. I'm one of the leaders in the Alberta Aurora Chasers community. I got started chasing the Aurora, actually started with storm chasing, and then I realized that there was a lot of similarity between chasing storms and chasing Aurora. Obviously not in the actual involvement in storms themselves, but in understanding the nature behind what's going to happen and how it might happen, and predicting when and where. And that's a large part of how we lead into the Alberta Aurora Chasers community, where we try to promote the science behind chasing Aurora. The Alberta Aurora Chasers community has been around since about 2012. Way back then, we only had a couple hundred members. We were at about 366, I think, in about 2013. Since then, we've grown up quite a bit, and we're now sitting just shy of 150,000 members. A lot of that is due to Steve and our interaction with the Aurorasaurus community. We've been working very closely with Liz's Aurorasaurus community since about 2015. And through the Alberta Aurora Chasers community, we promote sharing observations using Aurorasaurus, in addition to all the science and understanding of the basics behind how Aurora can form. One of the things that I really love about our community is the composition. We are currently 78% Canadian, and of our Canadian population, about 94% of that is Albertan. This is important for us because there's a lot of regionality necessary when you're chasing the Aurora. It happens in your particular corner of the hemisphere as night sky moves around the northern hemisphere. And it's also important to be able to know what the night sky conditions are in your area. Clouds, for example, are obviously a very big component when we're trying to see the northern lights. The growth chart of our community is also quite something. Back in 2016, 2015, when the Steve discovery was taking off, that's when our community started to really explode in growth. We started to get a lot of international attention, and we started to get a lot of national attention as well. And that really brought attention to our community and helped us grow quite a bit by leaps and bounds, really. In 2015, our growth curve looked a lot like it does in 2021 with that hockey stick shape. Recently, though, in 2021, in no small part due to the pandemic, our growth exploded. Back in March of last year, there was some pretty decent activity, and we had a lot of people who were stuck at home, and they were looking for things to do outside without being in indoor locations. Combine those two events, and we had a lot of people that became very interested in Aurora chasing. So much so that our community exploded. We nearly tripled in size in the course of a few months. It was really quite incredible. And a huge proportion of those members, 146,000 members, are very active, remain very active within our community. So we see a very, very active and very friendly sharing community, which is quite important. Another thing I love about our community are our demographics. When you compare our community, the Aurora chasing community, we have nearly 70% of our, 65 to 70% of our community is female compared to male, which is really quite fascinating. And there's all sorts of theories as to why. With Aurora chasing, the barriers to entry are a lot lower. You don't need to have expensive telescopes. As Liz mentioned, getting to the point now where top-end cell phones are actually getting quite effective at taking night sky photos. even with SLR cameras, you don't need an expensive camera to be able to take a good aurora photo. All you really need is something that you can control the exposure rates with and put on a tripod. And you can get a pretty decent photo of the night sky. Steve is a huge part of our community. We were, Southern Alberta, the southern half of Alberta is ideally located for observing Steve. Steve likes to show up over these latitudes quite frequently with the aurora. And we happen to have a population of a couple million in this area that are available to watch the aurora. And of those, several thousand are in our community. So Steve, as Liz mentioned, takes on many different shapes. And these are a few photos that I've taken in the last 2 years, where Steve has been moving across our sky and presenting its different faces to us.
Chris, can I just
Yes.
interrupt for a minute? We've got a question saying,
Sure.
I don't know what Steve is. Can you tell us, please?
Absolutely. So Steve is a phenomena that shows up sometimes when the aurora shows up. It tends to, it occurs south of the aurora boundary. It is, we call it a strong thermal emission velocity enhancement. That's what the acronym spells out to. And it is well, a lot of it is not unknown yet. There's still quite a lot of research that is going on into the topic. So when the question says, I don't know anything about Steve, a lot of us share that question, and we're still learning quite a bit about it. We do know that it is quite hot. We do know that it flows from east to west, and in the northern hemisphere. It also shows up in the southern hemisphere as well, with similar presentation, similar view. And we're still learning quite a bit about Steve. There's still some very new phenomena that are coming up. Recently, there's been an observation of Steve and star arcs. And there's some papers about how Steve and star arcs sort of interact and can transform into each other, or star arcs turning into Steve over the course of time. One of the great things about Steve and the Alberta Aurora Chasers community is the sheer volume of material that our community is able to generate and share within our community and beyond. A lot of our community members have been participating in scientific research and in papers. They've been co-authors in papers on the topic, and their well-documented photos and observations have proven to be quite valuable for these research activities. The story of Steve. Steve predates. Steve has been around for a very long time. Back in 2014, I saw the phenomena. That's not to say that I was the first one to see it by any stretch. And I asked around, what is this? And I heard that it was a proton arc. So we started calling it a proton arc. And then a year later, we learned that it isn't really a proton arc at all. Proton arcs are quite different. They are large, green, and quite diffuse looking, and maybe not even able to be seen with the naked eye. In 2016, Liz came to the University of Calgary. She gave us a presentation, and that evening we were talking about the phenomena that we saw. We learned that it's not a proton arc at all, and we were challenged to come up with a name, temporary name for it, until we could determine what its physical properties were. And then we played bubble hockey. A few weeks later, I had a hard time coming up with anything that we could call such a phenomena, and I brought it to our community. And I said, I propose we call it Steve. Really intended to be a conversation prompt to present something quite ludicrous and get the community to talk about and come up with a much better term. However, Steve stuck. And in the long run, it actually ended up being quite effective because after it was presented with the European Space Agency, many news agencies around the planet picked up on the fact that a bunch of Aurora chasers decided to start calling an aurora phenomena Steve. And the story went quite viral for several weeks and a couple of years annually, it seemed. Oops. Sorry. One of my favorite stories came out of Science Advances, where the author stated that citizen scientists, that this discovery, actually, what was it? Oh, this is our paper, sorry. This is the paper that Liz led. And what I really love about this paper is that there are two Aurora chasers, citizen scientists, included among the co-authors in this paper. We have no scientific background. Both of us work in telecom, and being able to be included on this paper was a huge honor and led to a lot of other Aurora chasers being included as well. And we've received awards from NASA itself. And Steve has since been commemorated in a coin in Canada, and the $20 Steve coin, which is really quite wild and crazy. And finally, a lot of students are, some students are including Steve in their science fair topics, which is exciting to see this being a hot topic for them to take over. And I think I am over time. I'm going to pass over to Jeremy.
Thanks. I'm going to share my screen. I'm going to do a bit of an abridged presentation here. I had a section on how you can shoot the Aurora and make sure that your stuff with your cameras is maximally scientifically useful. What I'll do instead is put that into a blog post on my website, CaptureNorth.com. I'm going to speak specifically from the viewpoint of being one of the Aurora enthusiasts who got involved in the citizen science aspect, and how I took my imagery to the next level, I guess you could say, by making it more calibrated and useful scientifically by building a robotic camera called AurorEye. Canada is an auroral observatory. We've got a lot of automated cameras up north run by places like the University of Calgary, and these are bear proof. They run autonomously and they've been up there for years. And they capture mosaics that can be combined and stitched together to cover all of Canada. And it's amazing what they do. But citizen scientists have a way of contributing as well. They can be positioned anywhere where there isn't clouds, as Chris said. And as Liz said, there's lots of people ready to do this. They can take pictures, but what I want to do is to make a self-contained, hands-off kind of R2-D2 of auroral imaging that you could just set up like a lunchbox on a tripod and let it run while you do your own photography. So think of it as R2-D2 to your Luke Skywalker. And this is to scale with R2-D2. It's a little lunchbox, sits on a tripod, and you just ignore it. You set it up. It's portable, self-contained, travel-friendly, goes in a plane, no problem, goes through security, and it's unsupervised while you do your own aurora photography. But what does it capture? It captures all sky imagery, meaning the entire horizon is a circle around you and the zenith is straight up using a fisheye lens, and this is what it can see. It doesn't miss anything because there's nothing to miss that's behind it. Everything is in front of an all sky camera view. And this is some imagery captured from it. You get images like this. And what can you do with these? Well, first they're calibrated. You know you're looking at the zenith straight up, magnetic north is straight up, and you know the characteristics of the lens. So a researcher can go back and actually do measurements on these images. It's also calibrated in time. Because you can see here, it's got a GPS in it. So no matter where you go, it knows where you got the imagery and exactly what time down to the second it was captured. This camera is just a simple APS-C consumer Canon digital camera, but it is more than sufficient for capturing time-lapse imagery that's calibrated. And I just put it in this little kind of Nanook, which is made in Canada version of a Pelican case with the lens sticking out of the top and a Raspberry Pi controlling everything, and then glove-friendly button interface on the side. You only really have to press start after you get it aligned. Here's how I calibrate it with the International Space Station. And you can see that the track of the space station is right where it was predicted, and that the images are right up against each other because there's no gaps in the trail of the space station. So I took it up to Yukon to test it in many places since then. These are the kind of images I captured. We went up to both Whitehorse area and a Midnight Dome in Dawson City, which is further into the Auroral Oval. So Midnight Dome, arrived there just at dusk, set it up on its tripod, and see it's got a little tilt thing to tell you if it's pointed right up at the zenith, and you let it run. Just press the start button. And then you could ignore it and do your own Aurora photography and get to know people and just have fun. And it ignores the headlamps and the car headlamps because it's 2 meters above eye level on a tripod. And it just captures images all night. In this case, 900 images or so. And you get something like these. The one on the right is after midnight with those pulsating aurora that Liz mentioned. And the one on the left is a substorm that took place just around midnight. And I won't play these entire things right now, but you can see that it captures some intriguing imagery, and also that the aurora characteristics are different before and after midnight. Here's another one with the galaxy overhead because it was no moon at all, some cloud cover, some light pollution, and then looking on the northern horizon, which is on the bottom, you'll actually see some of those red aurora that are higher up, like we saw in Liz's image of what the aurora colors really mean and what they represent. And then the pulsating aurora closer to morning, and finally sunrise. And this is just left out all night doing its thing, and then you gather up the imagery at the end of the night. You can also take individual images and process them because they're in RAW and get something a bit more dynamic and interesting that maybe you can hang on your wall. You can also take the imagery and turn it into kind of a summary of the night, sort of like an earthquake has a seismograph. You can take the center of an all-sky image and map it out into something called a keogram, which is like spines of a book in a bookshelf, to get a good idea of what happened all night in one glimpse. And you can also reproject that into a virtual dome and see everything that's above you and look around. This is something I worked on in conjunction with the University of Calgary called Keogramist. So virtual reality, I guess, with the images you've captured. So this is the tour we did, well, everything from Whitehorse to Hinton, Alberta, and hopefully Churchill by the end of the year. And what's next? We're going to build more, and we want to get the prototypes in the hands of Aurora Chasers. Feel free to get in touch with me at info@CaptureNorth if you're interested in learning more. Hopefully we have 1 or 2 minutes for questions, Lori. I'll let you take over at this point, and I'll just leave this slide up if you think that's appropriate.
Oh, thank you, Jeremy and Chris and Liz. That was amazing. We should have gotten you for an hour and a half, not just half an hour. Joanne had a question that said, "How could you do this from a boat?"
Well, you can definitely take Aurora pictures from a boat with a tripod as well. But and people do, there's tourism. If you're on a tour boat in Norway, our project has actually collaborated with Hurtigruten to do citizen science from some of their boats. So we can put a link to that in the chat from our blog as well. And I'm sure Chris and Jeremy may have some more suggestions. And I'm happy to take more questions in the chat. Sorry for the time.
Oh, we needed more for sure. Joanne said that she's going on a cruise to Norway, so I think she'll take that up. So thank you so much for coming for us. Thank you to Roland for bringing you on board. This is just wonderful. And if anybody else has any other questions, they can put them into the chat, or you can individually get a hold of these people. We'll put all their information in the resources section. All right. Does anyone else have any other questions that they'd like to ask at this time? Okay. Well, thank you again. And we'll and I'm sure that you will have other people from other centers sending you messages saying, please come for sure. So all right, we'll give everybody just a minute or so for just as a bit of a break, and we'll start again in just a minute or two. Thanks, everybody.
Thank you so much.
Thank you for coming.